Hi, good afternoon, everyone. Let's start with ISI PEA 2005 paper now. Okay, look into the first question, beta. It says X is binomially distributed. It's a repeated question. Actually, it came in 2004 also. So X follows a binomial distribution and you need to find the maximum value of the variance. So we know that if X follows a binomial distribution, then we know that the variance is actually nothing but NPQ. So this can be written as N into P, and we know that P plus Q is 1. So Q is 1 minus P. So it is going to be N into P into 1 minus P. So this is going to be NP minus NP square. And this is my variance, and I need to minimize this. So I will differentiate this with respect to P. So I will get N minus 2NP equal to 0. N 1 minus 2p equal to 0. So p will be half. Now I can just find out the second order derivative. And from here, I will get the answer as minus 2n. And we know n is always positive. So minus 2n will be negative. So therefore, maxima. Now the maximum value of the variance, you can just plug this value back here. So it is going to be n into half into 1 minus half. So n into half into half. So this is going to be actually n by 4. So we can go ahead and say that the maximum value of the variance will be n by 4. Okay, come to the next question. Again, a very easy question. So this goes ahead and says, you're given a function and the function given to you is fx is equal to x mod x. So we know that if I need to open mod x, this can be x if positive and it can be minus x if negative. So if I were to go ahead and open this function fx is equal to x mod x, this is going to be x into x if x is positive, and this is going to be x into minus x if x is negative. So we will get x square and minus x square respectively if x is positive and if x is negative. Now let's check the left hand limit. So for left hand limit, I'm going to put it in this part. So I will get minus 0 square, that means 0. And if I check the right hand limit, I'm going to put here. So right hand limit will be 0 square, that means 0. So since I'm getting 0 from both sides, that makes sense that it is a continuous function. Now let me go ahead and check the derivative. So if I just check f dash x, I will go ahead and get 2x and minus 2x. This is if x is positive and this is if x is negative. And again, if I just evaluate it at 0, this and this will give me 0. So it is also a differentiable function. So answer will be it is continuous and differentiable at x equal to 0. The correct answer to this question will be C. Okay, let's come to the next question. Again, a repeated question. It was asked in the year 2004 and has been asked in the year 2005 also. So this is your matrix given to you, and the matrix given to you is A is equal to 1, 2, minus 1 and minus 2. So if I just go ahead and find A square will be 1, 2, minus 1 and minus 2 into 1, 2, minus 1 and minus 2. So if I just go ahead and I solve this, this is going to give me 1 minus 2, minus 1 plus 2, 2 minus 4, and minus 2 plus 4. So this is going to go ahead and give me minus 1, 1, minus 2, and 2. So if you notice, this is nothing but if I just take minus sign out, and it will give me 1, 2, minus 1, and minus 2. So you need to notice that this is nothing but this was the matrix A. So this is my matrix A. So this is going to give me minus of A. So we have gone ahead and we have proved that if I find out A square is minus of A. Now A cube can be written as A square into A. So minus of A into A. So minus of A square. And A square was minus A. So minus of minus A. So A. So what are we coming to? What pattern do we go ahead and see? You can go ahead and find a to the power 4 also to verify this pattern. It will come out as minus a. So you will see that whenever it is even power, you will get the answer as minus a, and whenever it is odd power, you will get the answer as a. So what we can go ahead and do therefore in this case is that this is a to the power even power and plus a to the power odd power. So even power will give you minus a and odd power will give you a. So the answer to this question will be 0. So the correct answer is 0, 0, 0 and 0. Okay, come to the next question. It says you're given a function. It's a good question. It's interesting question. So you are given this function beta. The function given to you is x square plus 2x minus 3 in mod plus this is 1.5. So I'm writing 3 by 2 log x to the base e. Okay. Now this says you need to evaluate the function over half and 4, and you need to tell me where you are reaching the maxima and where you are reaching the minima. So what I can go ahead and do therefore is first I will try to evaluate this aspect of the function. So if you just go ahead and you notice, I will write this as x square plus 3x. I'm just factoring it out, minus x minus 3 in mod plus 3 by 2 log x to the base e. So this is going to be x plus 3 minus 1, x plus 3 and plus 3 by 2 log x to the base e. This is going to give me x minus 1 into x plus 3 in mod plus 3 by 2 log x to the base e. This is going to be my function, right? Now, because this is in the mod, I need to check where the function will be positive and where the function will be negative. So if you just try to evaluate this function a bit, you will understand that this, if I just try to see where this is going to be positive, so it is positive if both of them are positive. So, x minus 1 is positive and x plus 3 is positive. So x is greater than 1 and x is greater than minus 3. So this gives me that x is greater than 1 because I need to club the two things together. This is minus 3, this is 1. So greater than minus 3 and greater than 1 gives me greater than 1. Now the second part actually becomes what other time can it be positive? It can be positive when both of them are negative. So this gives me x minus 1 less than 0 and x plus 3 less than 0. So x less than 1 and x less than minus 3. Again, if I just try to club them out, I will get less than 1 and less than minus 3. So this is the common region. So this goes ahead and it gives me that x should be actually less than minus 3. So when x is greater than 1 or x is less than minus 3, it is going to be positive. And when x belongs to 1 to minus 3 to 1, it is going to be negative. It is going to be negative. Add minus 1 and add 3, it is going to be actually 0. Right? Okay. So now what I can go ahead and do therefore is I need to open up this function. So I'm going to go ahead and write this function as the same that was given to me, x squared plus 2x minus 3 plus 3 by 2 log x to the base e. This will be my function. And I'm writing it with positive sign. So the positive sign holds when x is either greater than 1 or less than minus 3. And the interval I'm given is half to 4. So the interval I am given is half to 4. And I have said that whenever x is greater than 1, whenever x is greater than 1, it will be positive, right? So from 1 to 4, I will therefore be in the positive side. So I can go ahead and say that whenever x is going to be between 1 to 4. And I can go ahead and I can put a negative sign with this. And this actually holds true whenever x is negative. And x is negative in this domain from minus 3 to 1. So from minus 3 to 1. But I am only concerned in this interval. So I will only consider from half to 1. So this gives me when x is between half to 1. Right, when x is between half to 1. I have got this side. So now I have been able to go ahead and at least define my function well. Now I need to find out the maximum and minimum value of the function. So what you can go ahead and do is, one way of solving this can be, of course, by finding the derivative, equating it to 0 and checking where you achieve the maximum and the minimum value. That can be one way of solving it. So you can go ahead and you can find out f dash x, and f dash x will be 2x plus 2 plus 3 by 2. So log x will give you 1 by x, right? And you can equate it to 0. So when you will be equating this to 0, you will be going ahead and getting that 2x plus 2 plus 3 by 2x is equal to 0. So this will go ahead and this will give you 4x square plus 4x plus 3 is equal to 0. And from here, you can go ahead and find the value of x. So minus b plus minus root b square minus 4ac by 2a, right? So this is going to give you minus 4 plus minus root 16 minus 16 into 3, 64 by 8. So this is not solvable. If you can notice, I'm not getting any roots of this function. So which implies that at least I am not evaluating this function between 1 to 4. I am not getting any roots of the function. I am not able to solve it for any value of x here, right? Now what secondly you can go ahead and therefore do is you can look into the second aspect. So you can go ahead and you can just find out this part. So minus x square minus 2x plus 3 plus 3 by 2 log x to the base e, right? And when I find the derivative of this part, when I find the derivative of this function, I will get minus 2x minus 2 plus 3 by 2 into 1 by x is equal to 0. Is equal to 0. So this will go ahead and this will give me minus 4x square minus 4x plus 3 is equal to 0. And if I were to go ahead and solve this, the value of x that I will be getting will be minus b plus minus root b square minus 4a c by 2a by 2a. So this is going to give me 4 plus minus root 16, and 16 into 3 is 64 plus 64 by minus 8, right? And this is going to go ahead and give me 4 plus minus root 80 by minus 8. So this can be another way, and then you can evaluate the function at these points. Now, here is, so you've done this thing, huh? Here is what is wrong with going ahead and following this approach. The issue is that although I have been able to find the derivative, so I'm checking where the function is changing its value, I am not checking what happens at the extremum points. I'm not checking what happens at the point where the function actually changes its shape. You know, I'm not checking what happens at 1. I'm not checking what happens at 4. I'm not checking what happens at half, right? So before I can go ahead and I can find the derivative and I can equate it to 0 and so on and so forth, shouldn't I be going ahead and shouldn't I be checking the functional values at these? Because for the derivative to go ahead and exist, you know, don't I need that? Because I am cutting the function at 1, isn't it? I'm cutting the function at 1. So if I'm cutting the function at 1, you see here, there is a cut at the function at 1. So if I'm cutting the function at 1, don't you think it should be very necessary that I get the same value of the function at 1? Only then I will be able to go ahead and solve for this, right? So when I just try to evaluate what happens to the function at 1, you will realize that this will give you 3 by 2, 0 here. And this will also give you 0 here, right? So now we know that the function is at least continuous at 1, right? The function is continuous at 1, right? This will give you 0 here and 0 here. So the function is continuous at 1. What about the derivative of the function? If I just try to evaluate the derivative of the function at 1, what happens? So if I just try to plug 2 into 1 plus 2 plus 3 by 2 into 1, and if I just put minus 2 plus 3 by 2 into 1 by 1, I will realize that here I will be getting the value as 4 plus 1.5, that means 5.5. And here I will be getting the value as minus 4 plus 1.5, that means minus 2.5. So you realize that this function where we try to find out the derivative is actually incorrect, because the derivative does not exist at 1, because the right hand derivative and the left hand derivative is not equal, right? When I'm evaluating at 1 from this side and when I'm evaluating this derivative at 1 from this side, I am not getting the same answer. So which means that because of the kink, the derivative of the function does not exist. It may be the case that at 1, there may be a kink that would have been created due to this function, and therefore the derivative of the function does not exist at 1. Now, in such cases, of course, I don't expect you to go ahead and start plotting this function. But the question is, how do I solve for it? Because my entire approach of finding the derivative and equating it to 0 is incorrect. And that should have been the first thing that you would have done, right? Although I wanted to show you how the derivative approach works, but the derivative itself does not exist in this case, right? So in this case, what you will go ahead and do is plot the function. You will plot the function, right? So what you will realize, beta, you will realize that once you have found out this f dash x, let's go back to this f dash x, right? This is my f dash x here, and this is my f dash x here, right? Let me just take this here. So what you will actually go ahead and realize, this is my f dash x when x is between, what was the interval of x I had taken here? Between 1 to 4. And this is my f dash x when x is between half to 1. So you will realize that because at x equal to 1, we know that the value of the function is 0, and which is very prominent from here because it was one of the roots of the function. And since the value of the function is 0 at x equal to 1, we need to see what happens when the function takes a value less than 1. So you will realize that here, when the function takes a value less than 1, if I put anything inside this part of the function, I am going to get a negative answer. My derivative is negative. And here, if I put anything more than 1, I'm going to get a positive answer. Just put 2 and check. And here, just put, say, 0.8 and check. Here, you will be getting a negative answer, and here, you will be getting a positive answer. So we realize that actually, we see that the function is decreasing between half to 1, and the function is increasing between 1 to 4. So it is decreasing between half to 1 and increasing between 1 to 4. And we realize that derivative does not exist at x equal to 1. It is a continuous function. We saw that the left hand limit and right hand limit are equal to each other. It is a continuous function, but the derivative of the function does not exist. So I cannot use that typical approach of finding f dash x and equating it to 0 like we usually do. So now what we can do is we can find, because this is decreasing and then increasing, so we clearly know that the function attains its minimum value at x equal to 1, right? And if I just find out the value of the function at x equal to 1, we actually see that it is giving us 0. So if I just put x as 1 here, I will get this is 3 by 2 log of 1, because this is becoming 0, 1 minus 1. So this will also be log 1 is 0. So the entire answer will be 0. So what I realize in this case is that the minimum value of the function will be 0. Just by looking there, I can go ahead and eliminate this and I can eliminate this. The minimum value has to be 0. Now I can go ahead and I can find the maximum value of the function. So if I want to check the maximum value, because this is decreasing and then increasing, I need to evaluate the function at half and 4. That's the only 2 points left. And you need to also go ahead and you need to also see that it could have been 2 ways. So something like this, maybe, then it would have been maximum at half, and the function could have been something like this, then the maximum would have been 4. So we don't know the exact shape of the function. So we need to evaluate the function both at half and at 4. So now if you just go ahead and you evaluate the function at half, right? You evaluate the function at half, you will get the value of the function as 7 by 4 minus 3 by 2 log 2. And when you evaluate the function at 4, you will get the value as 21 plus 3 log 2, right? And it is absolutely clear to us that this is getting added. This is 7 by 4, this is 21, this is 3 by 2, this is 3, and both have log 2. So clearly f of 4 is greater than f of 2. So we notice here that the value of the function at 4 is clearly greater than at half. So the value of the function is clearly greater than at 4 than at half. So therefore, we attain a maxima at 4, and this is the maximum value of the function, 21 plus 3 log 2. So this is a very good question because I wanted to kind of focus on a lot of things. Under usual circumstances, you would have gone ahead and you would have found out the first order derivative and equated it to 0. But this is a good question because number one, you kind of realize that here the derivative approach does not work because the derivative does not exist where the function is breaking. Number two, you realize because the function is given to you within some interval, you need to check the function at those interval. And therefore, the graphical approach seems to be very good, right? And the graphical approach kind of gives us a good analysis that we just want to evaluate the function at 3 points, the extreme point, and where the function changes its changes the curvature, where it changes the way it looks, right? And when you evaluate the function at these 3 points, it kind of helps you understand where the maxima and the minima is reached, right, beta? Okay, thank you.